My paper title: Growth, Spectral, Mechanical, Thermal and Optical Properties of Organic Envelope Crystals of cis-2,6-bis 4-chlorophenyl 3,3-dimethyl Piperidine-4-one. So this is for synthesis of method. So our compound was prepared by the reaction of ammonium acetate and 4-chlorobenzaldehyde and 3-methylbutane-2-one using the absolute alcohol as a solvent. So this is for our compound cis-2,6-bis 4-chlorophenyl 3,3-dimethyl piperidine-4-one. So this is image for the our grown crystal. The solubility studies, we have to the 4C3D MPO is tested with benzene and petroleum ether at 25, 35, 45 and 55 degrees centigrade. By the gravimetric method, benzene is found to be a most suitable solvent for these crystals. Another UV visible spectrum of this compound. So we have received the pi star and n star transition systolic MAC double beam UV spectrometer model 2202 in the range of 202 nanometer to 800 nanometer. So here there is no any observation from compound is colorless and transparency. So conclusion of this spectrum. Another FTIR spectrum of this study, grown crystal. So we have the two functional group is important, the NS stretching vibration and keto groups. So we have received the NS stretching vibration is around the 3300 and 1700 is the carbonyl stretching vibration. So we conclude our compound having the 4-chlorophenyl piperidine-4-one compound. Another one is NMR spectrum. So we have the many proton NMR spectrum is receiving some methylene and NH aromatic groups. There are the some splitting is there. Another C13 spectrum is we have received the we mentioned and calculated our paper is confirmed in. So confirmed with the proton NMR spectrum and C13 NMR spectrum. So thermal studies. So absence of the physical observed and lattice water is accounted for the any extended temperature up to 232 degrees centigrade, since weight loss occurring the beyond 230 degrees centigrade. A deep decreased weight loss is 47.46 percentage in temperature in 230 348 degree of the TG curve shows a partial breakdown of the compound. Further, the gradual decrease in the change of weight loss 39.02 percentage between the 348 and 498 degrees centigrade is due to a rupture of the compound. From the DTA curve is observed that material attained the solid liquid transition temperature at 150 degrees centigrade, indicative of the melting point of the substance, exhibit the stable condition up to 156 degrees centigrade. So we conclude the thermal studies, our material is thermal stability of the compound. Another Vickers microhardness test. So Mayer's laws related to load and size indentation as P equal to K1 dN, where K1 is a material constant and N is a Mayer index. The slope of graph of log P against the log D gives the value of N, and it is found to be 2. Hence 4C3D MPO crystals belongs to the soft material category. Another SHG measurement. The potassium dihydrogen orthophosphate KDP crystal is powered and it is used to reference material in the SHG measurement. The input layer energy incident light is 2.5 mg by pulse. The SHG is confirmed by the emission of the bright green radiation. The 4C3D MPO second harmonic signals of 45 mV is observed, while the KDP is gives a SHG signals of 18 mV for the same input beam energy. Thus, SHG relative efficiency of 4C3D MPO is found to be 2.5 times higher than that of KDP crystals. So our compound having the NO low properties. So conclusion, the single crystals of 4C3 MPO materials with good optical quality have been grown from benzene solution by slow evaporation technique at an ambient temperature. The characterization of the crystals has been carried out using UV visible, FTIR, proton, C13 NMR spectra, and thermal and envelope studies. The Vickers microhardness measurement studies show that crystal belongs to the softer material category. Further, the SHG efficiency is found to be 2.5 times higher than that of standard KDP, which suggests that 4C3DMPO is much useful material for the NLO applications.